In this video, we're going to look at solving irregular systems of three equations. So remember, from solving systems of three equations, we have three variables present, and the general rule is if you have three variables to solve for, you need three equations to do that. So what we have right now are three equations, but the setup is slightly different from what we saw before. In this case, we have an equation that uses the letters P and R, but we notice the second equation uses different combination. It uses the letters P and Q. So we see that there are three different letters in play. The last equation has a Q and an R. And so our overall goal from last lesson was, let's get two equations that have the same two variables. Then we can apply methods that we've already used in the past. Well, we have one little hurdle to get past here. Each equation has two variables, which is good, but none of the equations have the same two variables. So we have a couple of options here. We can make that happen. We can force that to happen by eliminating a variable. But when I use the elimination method, I prefer to have equations where I have common terms stacked. So if we just look at the first two equations up here, there's a P above another P. There's an equals above equals, and we have constant terms, -7 and -8 lined up. But in the middle, the issue here is that we have a 4R and a 3Q, a minus 3Q. And we can work around that, but it just seems like a little extra work when we have another method that we could use, substitution method. And so what I'm going to try to do instead is I'm going to use substitution method to allow me to create a new equation, and hopefully that equation has the same two variables as another equation in our system. So real easy here. We just start at the beginning and ask yourself, in this first equation, is there a variable that we can solve for? Pretty easily, with minor work, no fractions are going to be created from that. And if you notice the variable p in this equation, it has a coefficient of 1. So solving for this equation will take minimal effort. All we have to do is cancel this 4r, and we'll be done because we don't need to divide by any coefficient here. That should be always your goal. Always find a variable with a coefficient of 1 if you need to solve. So that's what we're going to do. And to reference our equations a little bit easier, I'm going to label each of these so I can call them something. So let's go ahead and give these equations names so we can talk about them later. Let's call this lowercase 1. This is Roman numerals. Here's equation 2 and equation 3. Okay. So we have our three equations here, and my first step is I'm going to take equation 1. So here's step 1. I'm going to solve for p. I'm just keeping track of what I'm doing in case I need to go back later. Solve for p in equation 1. So I'm going to put a circle 1 right here. Okay, so how do we do that? We take our first equation that said p plus 4r equals -7. To get r by itself, or to get p by itself, we'll subtract 4r on each side. And we end up having p equals -7 minus 4r. Okay, so p is on its own. But here's the idea that we now have. We have p is equal to -7 minus 4r. So anywhere that we see the letter p, we can replace with this idea, -7 minus 4r. Well, if you notice, we have another equation that uses the letter p. And so what I'm allowed to do now is I can replace this p right here with this expression. And that is the idea of substitution. So that's going to be my second step. Let me substitute in for this p. So here is my second step. I am going to substitute I'm going to substitute for p in equation 2 from the beginning. So circle 2. Okay, so that original equation said p minus 3q equals -8. If we replace p, I always use substitution when I or parentheses when I substitute. When I replace the variable p, we have negative 7 minus 4r from earlier. The equation still has a minus 3q and an equals negative 8. Okay, a little simplification here. We don't need these parentheses, so we have negative 7 minus 4r minus 3q equals negative 8. We can add this 7 to the other side. Okay, and that's going to give us a negative 1. And you'll notice over here we still have this negative 4r and negative 3q. I'm going to suggest every time you have multiple variables in play, put them in alphabetical order. So instead of starting with negative 4r, I'm going to start with this negative 3q and put the minus 4r afterwards. Okay, and here's the great thing about what we just did. We have a new equation now that has the letters q and r. And if you look up into the system from earlier, we have a second equation that already has those letters. And so we don't have to do anything else to find two equations with the same two variables. By going through this step one time, we already have this set up from this irregular system. So now we need to combine equation 3 with this new equation from step 2. So let's go ahead and do that over here in this space. Let's use equation 3, okay, and equation from step 2 right here, and let's eliminate. Well, let's choose one of the letters to get rid of. It doesn't actually matter. So we have the letters Q and R. Let's go ahead and decide to eliminate Q. Okay, so let's take our two equations that we had. We had Q plus R equals 1 from up above. And the equation we created was a negative 3Q minus 4R equals negative 1. And if we want to eliminate Q, we see here that they don't quite cancel. This Q is positive and that one's negative, but this is a negative 3. So we need a positive 3 Q in the top equation, which we can fix by multiplication. So let's do that. Let's multiply our equation here by 3. Okay. And so when we do that, this is going to end up saying 3Q plus 3R equals 3. We don't need to change the second equation, which will say negative 3Q minus 4R equals negative 1. And now if we combine our two equations, we're going to have the Q's cancel away. We're going to have 3 minus 4R, which is negative 1R, equals 3 and negative 1 combines to 2. And through a quick division right here, we can divide by negative 1. And we get R equals negative 2. Okay, so we are 1/3 of the way to knowing all of our variable values. We have R equals negative 2. We need the other two variables. And so now that we know this R value, we can put it into any equation we want to. So we have an R here and an R here. That's going to let us solve for a different variable. So let's go ahead and try that. So step 4 here, substitute R. And solve for, let's go for P. So let's go to equation 1, let's solve for P. So P said P plus 4R equals negative 7. But we know that R is equal to negative 2. So let's go ahead and replace that. So p plus 4 times -2 equals -7. A little simplification. We get p minus 8 equals -7. And then we can add 8, and we're going to get p is equal to 1. Okay, so there is our second variable. We still need q, so we find equations that have q in them. We can now put p into the second equation, since we know it's equal to 1. That's going to let us solve for q. Or we can go to this third equation. It looks a little more basic. We still know that r is -2. We can put that here, which will let us solve for the variable q as well. So let me create some space to finish this out. Okay, so here's my fifth step, and basically the last step. Substitute r and solve for q. Substitute for r and solve for q. Okay, so we have this equation down here. It said q plus r equals 1. So very quickly, if we had q plus r equals 1, and we know that r equals -2, we have q plus -2 equals 1. And that would give us the equation that reads q minus 2 equals 1. So add 2 to both sides, and we get 1 plus 2 over there. So q is equal to 3. And now that we have a value for each of our variables, we can write the final equation. Okay, and so, the final solution, the ordered triple, would be alphabetical order, where we have our three variables in alphabetical order, starting with p. We had a value of 1, q had a value of 3, and r had a value of -2. And that would be our solution to this system. Okay, so in the next video, we're going to look at systems that have infinitely many or no solution, rather than getting an ordered triple like we did here.